Welcome to day 14 of my Inventor.io 30 Days Lost in Space adventure. Unfortunately, this is the second time I've had to record this because I had the original recording on my camera SD chip and inadvertently deleted the footage before I had a chance to render it down into the YouTube video. But there really wasn't much from the overhead view that I was showing. I was mostly going over the additions on the keypad project, where we moved two of the pins over to non-PWM generating pins, and then we utilized red, green, and blue PWM signals to the multicolor LED to give us some haptic feedback from when we put in our password. It would prompt us to put in the password, and then when we put in the password, it would light up blue. If we put in the correct password, it would light up green, and if we put in the wrong password, it would light up red. So the rest of the video is the computer view, and we will go into that and take it from there. Okay, so in the computer we could see that we have the multicolor LED, red, green, and blue leads with the ground in the middle, being fed by the 3 resistors. Here we have the connection to the buzzer. It's hard to see the pin section here, but if I blow up my screen a little bit, we could see that pin number 8 is a non-PWM feeding the buzzer positive side. We have the ground that goes to this common rail at the bottom, feeding ground to the LED and ground to the buzzer as well. We've got the 3 PWM signals for 11, 10, and 9 feeding red, green, and blue respectively. And then, like I said, we have the 2 pins on the far end of the numeric pad feeding these 2 non-PWM signals here. So looking at the code, we can see that there's a couple of similarities, but there's also a lot of things that are different. We'll add our keypad.h. We'll create some integers for our buzzer on pin number 8. Our red pin is on 11. Our green pin is on 10. And our blue pin is on 9. Don't forget, you could also do these with pound define. And we could say red pin 8 without an equal and without a semicolon. I keep wanting to call them end of block because in the CNC world, a semicolon is considered what they call an end of block. Then we create our byte constants for our rows, our columns, our password length. We create an array that says that the variable password has a length of 4 because of the pass length right before it. Copy and paste this to spare some time. Create our 2-dimensional array saying that it's 4 rows, 4 columns based on this information up here. Same thing, I'll just grab this. We'll say that our row pins fall in on pins 13, 12, 7, and 6. Because we moved those 2 pins over from 9 and 8 to 13 and 12. Our column pins remain the same because they didn't move. Create our key map. Now we'll create a couple of different functions. We're going to create a function called play success. We're not passing any variables. We're using the tone command. We're applying that to buzzer, which, if we remember, is just pin number 8. So we're saying tone output to pin 8. And a tone of 370, the 1000 after. We're going back to using the RGB color function that we created a few days ago. And we're delaying for 50 milliseconds before we do a no tone on the buzzer. Create another function called void play error. And basically the same thing. It's going to apply a tone to buzzer of 147 with a 500 delay. Back to the RGB color. And again, remember the first one is red, the second one is green, the third one is blue. So when we have a successful action, we're going to use this play success function to display the green color and use a tone of 370 on the buzzer for the 1000 delay time. So what these are doing is we have a tone that delays for 50 milliseconds before it turns off. So we just get a little beep, beep, beep type scenario. So we have three play functions. We have success, error, and play input. So each one, really the only difference is that each one's going to play a different tone for a different allotment of time. But ultimately, the functions are the same. It's just the input data that's a little bit different. And underneath all of those, we then create our old friend, the RGB color function. Now we create another function, and this function's pretty long. I mean, all things considered, it's pretty long. So the function that we're going to create now is called unlock mode. And I know this function ties back to a few days ago, but because I'm recreating this every single time, it's just good practice to do it this way. You could copy and paste if you wanted to, but I like the fact that by typing it in, it helps with muscle memory, so it helps retain the information. That's why I've been crunching all the numbers and stuff into the actual programs every time we go to these views. So first thing we do is we create a custom key char, and it's equal to custom keypad.getKey. When we go into this unlock mode, it goes to serial print line and it says unlock mode, type password to continue, and then we delay for a half a second. Underneath that is a for, which is another version of a while loop. We'll initialize an integer I of 0. We'll say if I is less than pass length, run this function, and every time it runs, increment up 1. But inside the for, we have a while, and while custom key equals custom keypad.getKey is not active, we just wait forever for user input. Underneath that, we say if password I is not equal to custom key, we will then serial print line wrong password. And then we serial print line custom key, which is the keystroke that was incorrect. And then we jump into the play error function, and we return a -1 value. Underneath that, we serial print the asterisk to mask the character input, and then we use the play input function to play the different sound effect for the buttons being pressed. Underneath that, we do serial print with double asterisks and serial print line device unlocked. And if the device was unlocked, we then play success function and return 0. Which brings us to our setup section. In the setup section, we're just assigning our pin modes for red pin, green pin, and blue pin. We're also using the RGB color function set to 125, 125, and 125, which gives us a white light. We're beginning our serial monitor, and then we do a serial print line, press star to enter new password, pound to access system. Inside of our loop, we do char custom key equals custom keypad dot get key, and then we say if custom key is equal to star, we then create an integer called access, and we call the unlock mode function, and then we say if access is less than 0, so if it returns the -1, we then serial print line access denied with an RGB color of red. Else we serial print line welcome, please enter new password. Delay for half a second, and then we create another loop. So for int I equals 0, I is less than pass length, count up with I++. Then we have while not custom key equals custom keypad dot get key, and then again we wait forever. And if all is successful, we print out password changed and we play the success function, close out our custom key if statement for the star, and then we have if custom key is equal to pound. Jump into unlock mode, go through the motions inside of unlock mode. If it's returning the -1, we say access denied. Else we say welcome, you may enter, and then we play the success tone. So that's pretty much all it does. We just dive into either success, error, or input depending on where we are in our program. Depending on the return value, it'll either output access denied, or it will allow us to either unlock and set a password or unlock and enter the system. So let's verify that. I missed the C. Looks good. Plug in the hero board. upload the sketch, go to our serial monitor, and it will say press star to enter new password and pound to access the system. So if I press the would-be pound key, it'll say unlock mode, type password to continue, and I can type in the password. When I press the buttons, it gives me the happy tone to let me know that it's accepting the input, and the light turns blue. When the device is unlocked, it gives me the happy tone to let me know that I may enter. If I press the star key, it'll say type password to continue, and I can put in my password. If I get a wrong number, it says access is denied. It plays the error tone, and it shows me the button that I pressed that was incorrect, which was 5. Press star again. I'll put in the proper password. Now it'll prompt me to enter a new password, so I'll just put in something. It'll change the password. Try it again to access the system with the pound key. Put in the new password. And everything seems to be working as planned. Gives me a green light to let me know that it's happy and it's ready to enter the system. Gives me a red light when it's in an error state. Gives me blue when it's in an intermediate stage, putting in key inputs. And it plays all of the necessary tones. So that'll pretty much wrap up day 14. There is a lot going on in here, and I do plan on going back over this a couple of times because I'm still having an issue with freestyling a little bit, but I think that's going to be what day 15 is all about. It's more freestyle. They give you some pointers in the previous 5th day videos to try different things, and so far what they've suggested trying to do has been pretty successful. I am having a little issue just coming up with things off the top of my head that I want to program and work with, but I think that just comes with time. So that's it for today. Please be sure to like and subscribe if you're enjoying the content. I hope you guys have been enjoying the other videos that I've been putting up for the EMG Precision Tool Setter and the MCO PC Turn 55. I am going to get back on my SX3 mini mill very soon. I've got some pretty cool things planned for that in the future. So be sure to ring the bell to be notified of all my video updates, and if you want to check out the Inventor.io 30-day kit, feel free to check out the link below. With the coupon code, you'll save 10%. And be sure to stay tuned for the upcoming unboxing and overview of my Inventor.io beta test program kit. It's pretty exciting that they sent me a toolbox filled with boards and sensors and solar panels and things like that to try out to help with their beta program. It's really neat stuff. I can't wait to dig into that and really get my teeth sunk into this Arduino programming, because I see a lot of benefit to it, and I see a lot of benefit to not only old guys like myself, but also this is fantastic for the younger generation. If anybody watching's got kids, definitely look into this stuff. Try to inspire them to try the courses and get them on their way to creating these Arduino programs, writing code. There's a great career future in it. There's also a lot of fun that you can have with it. I'm only scratching the surface, but I just know from pretty much a lifelong standpoint where I would have been so much better off had I known how to do certain things with programming languages. And it's kind of a bummer that these things didn't come out 25 years ago, but that's life, and that's just the way that things kind of go sometimes. But there's never a time where you have to stop learning. You know, I'm not a spring chicken anymore, but I'm definitely learning a lot with this stuff, and I plan on continuing forward with it. And that's really what the end game is. Just never stop learning and always try to improve. So thank you for watching, and we will see you soon.